Alright, we're about to start learning about slope, and we're going to do this in the next couple classes. This is, in my opinion, the most important topic we learn in all of 8th grade. And so it says we'll be able to find the slope of a line in a graph using rise over run. And that's a definition that we often refer slope to. Another one is the steepness of a line and the constant rate of change. So if you've ever been skiing, you know that a ski slope, the steeper it is, the faster you're going to go down the hill. And you can see these have different slopes over here. This one looks to be pretty steep. This one, not as steep, right? Whereas this one right here in green, pretty steep. All right, we use the letter M to represent slope, and then we read slope from left to right. And you might mess that up, and I'll explain that that won't be that big of a deal if you do, but I think you'll get yourself in good habits if you read from left to right. So right here, if I am reading from left to right, since it's going up, it's rising, we consider that to be a positive slope. If you look at this part right here in the second rectangle, from left to right, the line's falling, so the slope is considered negative. On this one, it's not rising or falling, so we consider that to be a zero slope. And then if it just dips like this, like it's a big cliff, we consider that undefined. So again, slope is M, slope is rise over run. I didn't say this, but slope is vertical change divided by horizontal change. And the vertical change, vertical is always Y, so we say that's change in Y. Horizontal change is change in X. It's a lot of vocab, and that's why when you practice this, I think it's a good idea. This is a homework assignment. You have slope, and then you have the definitions for slope on the other side. It's a great idea to practice this 5 minutes a day until you feel really confident about the various definitions. There's a lot of synonyms for slope. You can see it with numbers now. What I mean by rise is we're rising up 4 units here. 1, 2, 3, 4, and then we're running to the right. 1, 2, 3. And just for reference, up is positive. Think about a thermometer. If a thermometer climbs, it's positive. If it starts to dip, that means the numbers are getting lower, so that you could have numbers hypothetically under 0 with temperatures. You can also think of elevation. Elevation is another thing. If you go below sea level, that's considered negative. If you think about some of the tallest mountains, that's considered positive. To the right is positive. Think about a number line for that. And to the left is negative. For most of this activity, it says find 2 points on the line. The 2 points here that I'll look at are the ones that are already dotted. And what you're going to do is use the line segment tool. So that's this tool right here. And draw the change in Y. So this symbol for the triangle is referred to as delta in Greek. And it means change. So if we're looking at the change in Y, I'm going to start from left to right. So I'm going to start right here. And they're talking about the vertical change. So I go all the way up so that I'm even with this other point. From there, step 3, we keep using the line segment tool. But now I'm going to show the change in X. And that's going to be in green. So I'm going to change the color here. And the change in X, as it says right here, you move the line horizontally. So off to the side, I'm just going to note this. It looks like I started right here. So if I count this, this is always point, like if I'm counting at 0, if you've played board games, that might make sense to you. 1, 2, 3, 4, 5, 6, 7. So that's a rise. Positive 7. 1, 2, 3. So the run, positive 3. So when I write this, M equals, it goes back to those definitions, but M is the same as change in Y over change in X, or rise over run. So since we rose 7 and ran 3, it's rise over run. Math symbol, so rise over run will be 7 over 3, and that's your slope. You might want to pause the video right now and try this one on your own at slide 6. Okay, if you were stuck here, that's okay. It's pretty new. Let me go through it. So again, we find 2 points. And this time they gave you 3 points, so that might have thrown you off. It actually doesn't matter which points you choose to use. I'm going to use the 2 points that are closest to one another. We're going to use the line segment tool, so I'm going to click here. Change in Y is in blue. So we start from left to right. So I'm starting here. I go down 3, and then I'm going to use the green, and the horizontal change, the change in X, is only 1 this time. So the rise is -3 because it's going down, and the run is +1 because that is going right. So when you do step 4, write the slope as a ratio. Again, that ratio is change in Y, the change in the blue, over the change in X. So I would write -3 over 1. And that's really the same thing if you divide by anything by 1. That's really the same thing as -3. Whoops. Now just to show you, if you use different points, you'll get the same answer. Let's say I accidentally used the point on the right and tried to go from right to left. And let's say I use the 2 points that are furthest apart, so this point right here and this point right here. I would say that that right there is a rise of 1, 2, 3, 4, 5, 6. So the rise is 6. And the run is -2. So if I express that as a ratio, the change in Y divided by the change in X, it's 6 divided by -2. And that is also equivalent to these ratios. So it really doesn't matter that you start from left to right. I think it's easier. We can all speak the same language about how we get the answer. And it also doesn't matter which points you choose. But again, I think it's easier to use the points that are closest together because you're having to count less spaces. Alright, if you want to stop watching the video at this point, you feel like you've got the concept down, you can do that. I'm going to show you one more in case you feel like one more problem will help you. So we find 2 points. I'm going to use this point and this point. So if I'm looking at the left, I'm doing this point first. The vertical change, the change of Y, looks like it's 3. And then the change in X, the change in the green, looks like it's 2. And I'm going up, so that's positive. Think about a thermometer. And I'm going right, so that's also positive. So this would be, change in Y would be 3. And the change in X would be 2. And so when they say simplify the constant rate of change is another one of those definitions for slope. And so we can say that it's 3 over 2. And when they say simplify, this is okay to have an improper fraction. I think it's easier because it helps us recognize, oh, 3 means that's how much Y is changing by, and 2 means that's how much X is changing by. So it's kind of nice to have an improper fraction in this instance.